Alright, so I've gathered all my materials together, my index cards, my pencil, my markers, the ruler, and some scissors. And so, yes, these are rectangles, and so my camera's kind of at an angle, so it looks a little bit weird. I will occasionally move the camera or move the index card so you can see that they are actually rectangles and not trapezoids as they look from that angle. Some things that I know about rectangles: I know that I have 4 90-degree angles. I know my opposite sides are congruent, and my opposite sides are also parallel. And so I know that my rectangle is also a parallelogram. I'm going to begin by marking my rectangle, and I'm going to call this side my base. And this side my height. So I have my base and my height of my rectangle, and I can measure it. And when I measure it, I'll see that I have a base of 5 and a height of 3. And so this is a 3 by 5 rectangle. 3 times 5 is 15, so that's 3 inches times 5 inches, so 15. And then inches times inches is inches squared. So this is 15 square inches, or 15 inches squared for my area. All right, so what I can do, and again, I want to talk about area as being the amount of stuff that's here. So in this instance, it's the amount of paper, right? So the amount of paper that makes up this rectangle is the area. So what I've done here is I went 1 inch in over here and 2 inches in over here, and I drew this line. Now it's important to remember that this line is not the height. So that's important. So my height is never going to be slanted. My height is going to be perpendicular to my base. So here's my height, here's my base. This line is not the height. Now what I'm going to do is I'm going to cut it along this line. And so now that I've cut it, did my area change? And so the answer would be no, the area didn't change. If I talk about the area as just being the amount of paper that made up this index card, well, the amount of paper didn't change. It's exactly the same. I can do a few things with this. If I looked at it like this, did the area change? And the fact is, the area did not change. What changed is this is no longer a rectangle, and this is some other polygon with even more sides, but the area is the same. Did my area change if I do it like this? Of course not. Still the same amount of paper. Did my area change now? And of course not. So what we know is my area is still 15 square inches. It did not change. Well, what I can do is I can set it up like this, and now what I have is I have a parallelogram. So I have a parallelogram with 2 sets of parallel sides. Opposite sides are parallel, opposite sides are congruent, but my area is the same. You got to remember that this here, my height, so the height of my parallelogram is never the slanted thing. Never the slanted thing. My height is always perpendicular to the base. So I have my base and I have my height. And so this is not the height, this is not the height, this is still the height. Height of my parallelogram is perpendicular to my base, and my area did not change. My area is still my base times my height, meaning that my area, and I'm going to recommend that we just keep bringing everything down on our equations, because this is going to be really helpful when we start solving equations next week. So area equals base times height. Well, my base was 5 inches. My height was 3 inches. Area equals 5 times 3 is 15, and inches times inches is inches squared. So my answer is area equals 15 square inches. And so that's why on our MVP, it says that for a parallelogram, it's the same as it is for a rectangle, which is just base times height, because my area is exactly the same for a parallelogram as my area is for a rectangle. It did not change. All right, so for our second figure here, I'm going to start off with the exact same thing. I'm going to start off with my rectangle, and I know that my area is just my base times my height. But what I want to do is I want to take my rectangle and I want to cut it in half. And so to do that, I'm going to just draw a line across my diagonal. And I'm going to cut along this line. And so when I've cut across that line, did my area change? Did the amount of paper that makes up this index card change? And the answer is no. So it's still, in this case, 15 square centimeters, as we remember from the last example. So my height is still perpendicular to my base. That didn't change. That's still a 90-degree angle. And my area didn't change. If I did it like this, there I have a parallelogram, but my height did not change. My base did not change. My area did not change. So what I know about my rectangle here is that my area is just my base times my height. But what's important here is when I have a triangle, I only have half. So this right here is half of this complete figure. So my area of a triangle is area equals half base times height. And so this case, my area is 1/2 times 5 inches times 3 inches. And since multiplication is commutative, I can do this in any order I want. So I'm going to multiply 5 times 3 first. And so 5 times 3 is 15. Inches times inches is inches squared. So now my area is just half of 15 inches squared, or 15 square inches. Well, half of 15 is 7.5. And my units are square inches because I am talking about area. And so there we go. My area of a triangle is just half of a parallelogram. And that's true because any triangle, if you double that triangle, it forms a parallelogram. Always. I challenge you. Pause the video right now, draw some triangles, double the triangle by folding the paper over and retracing it or using some tracing paper. And what you're going to find out is that any triangle, if you double it and then move it over, it's going to form a parallelogram. Let's make one that's a little bit different. So I'm going to measure 1 inch coming from both sides because I want it to be parallel. So I need my measurements to be the same. So I'm going to measure from my 1 inch mark to the corner. And there we go, from a 1 inch mark to the corner, 1 inch mark to the corner, and I'm going to cut this out. Alright, so now that I've cut this, I've made my parallelogram, but I want to identify a couple of pieces first, just to be consistent. So I'm going to call this down here my base, and I need my height. Now again, the height's never the slanty thing. The height is always going to be perpendicular to my base. So here I have my base and my height of my parallelogram. And I know it looks weird because it's at an angle, but we measured it and it actually is a parallelogram. Alright, so there's my base and my height. And what I'm going to do now is, just like I did before, I want to go ahead and cut my parallelogram in half. And so I went ahead and I left that line just so we can see that that actually is the height. So I went ahead and left the height line there. We talked about that already before, how the height can be inside, it can be outside. And so because of the nature of this particular triangle, but this triangle is now half of that parallelogram. And so my area is still 1/2 base times height. So the area is exactly the same as it was. My formula didn't change. It's half of my parallelogram, and so it's 1/2 base times height. And for our last example, we're going to go ahead and come back to the rectangle, which is height perpendicular to my base, and my area is base times height. I'm going to do like I did before and cut this along the diagonal, make my triangle. So now I have area equals 1/2 base times height. And I'm going to go ahead and do one more thing to it. But I'm going to come in 2 inches. And I need to know the halfway point of my triangle. And the easiest way to find a halfway point, sure, I could measure, divide by 2. But when working with paper, we can just fold it. And so there's my halfway point. And so I measured 2 inches in, and the reason I did that is just to make the calculations easier, because I'll know what the measurements are. So when I measure it, I have until my line is 3 inches, and then after my line is 2 inches. So it's a 3 inch, 2 inch, so that's still 5 inches. And so this is still a 5 by 3. Half of 5 by 3 is 7.5. Haven't done anything new yet. What I'm going to do is I'm going to now cut on my line. So I know I have my triangle here. My area of my triangle has not changed even though I cut it. But what I see now as my base is actually in 2 pieces. So I'm going to call this base 1 and base 2. They're still part of the same base, but now it's just in 2 pieces. What I can do here is I can just take this piece, rotate it 180 degrees, stick it on top, and now what I have formed is a trapezoid. And so my bases being the parallel sides, so I have my parallel sides are my bases, and I have my height, which is perpendicular 90 degrees from my bases. So I have my bases and my height of my trapezoid. Now this is a right trapezoid, but the same idea will work if you use a different trapezoid, as we'll see in a moment. From my triangle to my trapezoid, my area does not change. All I'm doing is rearranging the pieces, and it uses the same amount of paper. So my amount of paper didn't change, my area did not change. So my area of my triangle was easy. It's just 1/2 base times height, except on my trapezoid, my base is cut now into 2 pieces. I have base 1 and base 2 times my height. Now, again, we measured it to make it easier. So my base 1 was 3 inches. My base 2 was 2 inches. And my height is 3 inches. So I can fill in all my pieces. 3 plus 2 is 5. Inches plus inches is still inches. Bring the rest down. And now this looks exactly like it did when we had our triangle. So area equals 1/2 of 5 times 3, which is 15. Inches times inches is inches squared. Well, 1/2 of 15 is 7.5 inches squared, or square inches. So my area of my trapezoid is exactly the same as my area for my triangle. All I did was just cut it and move a piece of it over. Alright, so that's the end of the lab. Let's look at a couple of textbook pages real quick, and then you guys can get to work.